Hello, my friend. Welcome to my channel. So today I'm going to discuss confidence interval for proportion. In the previous video, I discussed about confidence interval for the population mean. So here we are going to look at proportions. This is the example. A sample of 500 nursing applications included 60 from men. Find the 90% confidence interval of the true proportion of men who applied to the nursing program. So this is a problem related to the proportions. So let's look at the information here. The sample size is 500. As you can see, the characteristic of interest is the number of men who applied to the nursing program. So here that number is 60. So characteristic of interest, the value is 60. And then you know how to calculate the sample proportion, which is p hat equals x over n. 60 over 500, which is 0.12. And then you know how to calculate q hat is 1 minus p hat. 1 minus 0.12, which is 0.88. And now we are looking at 90% confidence level, right? Confidence interval. So then the confidence level is 90%. So let's look at the formulas first. This is how you construct the confidence interval. Sample proportion minus margin of error. Population proportion less than sample proportion plus margin of error. So the margin of error in this case, the formula is Z score corresponds to alpha over 2 times P hat times Q hat over N and whole square. So as you can see, we need P hat, Q hat, sample size, and Z alpha over 2 to calculate the margin of error. So let's find this one because we know P hat, Q hat, and N. How do we calculate Z score corresponds to alpha over 2? Alpha is the significant level. So 1 minus significant level equals the confidence level. Confidence level is 90%. So then alpha is 1 minus 0.90. This value is 0.10. As you can see, we have to look at the probability in the tails alpha over 2. So let's find alpha over 2 here. 0.10 divided by 2, 0.05. So you have to look at two tails. One tail is this area under the curve is 0.05. So then the other tail also area under the curve is 0.05. The middle part is 90%. And you are looking at z-score. This z-score is negative. This z-score is positive, alpha over 2. This alpha over 2 value is 0.05. So let's look at this z-score. If you look at the table, z-score table, locate this probability inside the table and then locate the z-score. You will see this is negative 1.6 and the second decimal place is 0.05. So this is negative number, right? But we only need a positive z alpha over 2. Z alpha over 2. So z alpha over 2 value is 0.05. So z score corresponds to the area. C 0.05 equals 1.65. Okay, just the positive value. And now let's calculate margin of error. Z alpha over 2 is 1.65. P hat is 0.12. Q hat is 0.88. Divide by sample size is 500 and then whole square. So this value is 0.024. So we have the margin of error. Now let's calculate the confidence interval like this. P hat is 0.12 minus 0.024 less than population proportion. Sample proportion is 0.12 plus margin of error 0.024. So this is 0.096 less than P 0.144. So as a percentage, this is 9.6% less than P less than 14.4%. So now we are 90% confident that the percentage of applicants who are men is between 90.6% and 14.4%. So this is how we construct the confidence interval for proportions. So as you can see in this case, we had sample size and the number X value, right? So in some situations, you will see P hat directly as a percentage. So you can use P hat direct percentage. This is a proportion, right? So in this case, we had to calculate P hat using X over N. In some situation, you will see P hat directly as a percentage. Okay, so if you have any other questions or concern, please comment. And thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.